search tree? What are the topics that has been pending in a binary search tree? We have seen some of an operation in a binary search tree, and I'm asking you what are the topic has been pending in the binary search tree.
Deletion.
Deletion.
Then deletion and
In order, post order, pre order.
pre-order. Yes, deletion and traversal method. How the data will be, how the elements will be traversed from the root node to the leaf node. So these three method, this traversal method, deletion, and one more operation will be there. It is to finding out the maximum and the minimum in the tree, maximum element and the minimum element in the tree. So these are the three operation has been pending. So you will see one by one. First, we will move with the traversal method. So you all know that what is meant by traversal method, right? Yes. So this is the code we have discussed. We have defined a class, defined an object, and after that insertion method has been discussed and search method has been discussed. So after the search, we want to find out the traversal method. It will be consist of starting from the root node to leaf node. There is a three type of traversal method will be there. One is pre-order, post-order, and in-order traversal. So you all know the operation about these three things, right? What is meant by pre-order, post-order, and in-order?
In order, the root node will be in middle, sir.
Okay. Pre-order,
First,
post-order.
last, sir.
Yes. So this is an example I have taken. So now you can tell me the tree structure of this. So this is the example I have taken this. So now you can tell me the tree structure of this.
27 is root node.
27 is my root node. Then
Left 14.
left 14,
Right 35.
right 35.
For 14 left and 10, sir.
10.
For 35
Right
left
19.
19.
Whether 35 left to 19 or 14 right 19.
14 right.
14
14
right.
right. So in the 19 is less than 27. So it will move to the left hand part. So 14 left will be the 19. And where the 31 will be coming.
35 left, sir.
35 left.
35 left will be 31.
41. Right will be 42.
Right 42.
42. So this
Finally,
is how the insertion method will be happen. So now you can tell me what is, now we will discuss, first we will discuss about the pre-order. Now how the value will be there for the pre-order?
node left and right.
10.
Pre-order, the first what will happen?
Node
Node will be there. So what is the first element will be inserted?
27.
27.
27, then
14.
14, then
10.
10.
10, then
19.
19.
19. So in this case, what has happened? This left-hand side part has been completed, right? So first you have inserted this node, and after that this node, and the left-hand side of this, and left-hand side of right-hand side of this. So first it will be completed, and after that this part will be completed. It means we have completed the root node and as the left side node, and now we will move to the right side.
35.
35,
31.
31.
31
31,
42.
42. So you all know that, right? So this is the pre-order technique. So how we want to write this in the code? So this is the pre-order technique. We have insert an element and we have search sum of an element. Whatever required, we have search sum of an element. And what is the pre-order? You know the pre-order technique, and you can tell me now how you want to write the code. Not in a lines of code first. Just explain me. Generally, you can explain how you want to write it.
First calling node of main nodes, root node.
Root node, right? First, we want to call the root node, and you want to print the root node first. That is the first step. And after that, we want to check whether the left child is available or not. And if it is a left child, then the root node will be changed to the left side node. And after that, again it will check. So the regressive technique will be happen, right?
Yes, sir.
Yes, I'll write the code first. So I am declaring a function called pre-order. Whether you want to pass any arguments here for pre-order technique.
Yes, sir.
You can see here in the insert function, we have passed one argument, that is data. It means we are going to insert a particular data. In search function, we have passed one argument called data. That is, we are going to search that particular data is found or not. And here we are processing the pre-order technique, whether we want to pass any data here. Are you getting my point? Whether so here what is happened? I want to insert the node one by one. So I want to pass 3, 4, 5, 6, 7, whatever it may be. I want to pass one by one here. And here in the search method, I want to search any one of an element. So I am going to pass either 6 or 7 or 9 or 10. Any one of a number I want to pass here. Am I right? Whether in a pre-order technique, we want to pass any data or what?
No, sir.
No, we want to call the default argument. That's it. So we have created a function. Based upon this function, we want to call those function outside the. So first, what we want to print here?
Root node.
Node.
Yes, print. It's a root node is the self dot key is my root node, because we have see here self is my key is my root node. That is the first node that was taken. So here the self node key is my first root node. Am I right?
Yes, sir.
Yes, this 27 will occur here as my self dot key. So you can see here this 27 is my root node. Am I right? Yes. You can see here in a class, we have created an object and we are passing an argument that is 27. This 27 is mentioned as key here. And here the self dot key is equal to 27. So it means 27 is my root node. So I am going to print that self dot key. That is the thing. And after that, what I want to do?
Whether left side node will be available or not.
Yes, you want to check self dot L child. Whether we want to check whether self dot L child is available. If self dot L child is available, self dot L child dot pre-order. Again, I want to call this regressive function. What will happen? What will happen? You just see here, the code will be here. So here, I am printing the self dot key. So I am printing the self dot key. Again, I am checking whether self dot L child is available. Yes, the self dot L child is available here. And after finding out the self dot L child, first what will happen?
It takes the left.
This entire part will be executed first. This entire part will be executed, and this has taken and this has been printed. And again, what will happen? This statement will be passed. This statement will be passed, and this statement will be executed. Why? Because we're calling a regressive function. So now the self dot key value has been changed to 14, right?
Yes, sir.
Yes. Are you getting this? So here you can see first in the first part, this node has been executed. First part, this node has been executed and it has produced the result. And now it was checking the left hand side whether it is empty or not. If it is not empty, this part will be executed. It means that this statement will be produced now. So this condition is passed. Now this condition is passed and this statement will be produced. So now what will happen? If self dot lchild dot preorder, again it will go here to the preorder function. Now the self dot key is, now we want to print the self dot key. Now the self dot key is 14, so it will be print 14. Again it will go self dot lchild is present or not. Whether 14 self dot lchild is present or what? 14 is my root node now. Whether for 14 left hand
Yes, sir.
side, left child is present or not? Yes, left side is present. So now what will happen? This statement will be executed and this statement will be passed. So now this has been passed and this has been passed. Now this statement will be executed. Now this is my self dot key. So self dot key value, and again it will go to the print statement. It will print self dot key is 10. So again it will check the if condition. Self dot lchild is present. Whether self dot lchild is present for 10.
No, sir.
No, it means the if statement has been terminated. So if the if statement has been terminated, again we want to go for an if condition for checking the right child of the last node. Self dot r child. We want to check whether the self dot r child is present. Self dot r child dot preorder. And if this statement is false in this here, and again it will be checking that here the cell, it will reverse the statement and it will go here to the 14, whether it will check whether the self dot r child is present or what. Yes, the self dot r child is present for this particular statement, so it will produce the result as 10. And after this statement has been completed, now this 14, 10 and 9 has been completed and 27 has been completed. And now again it will go to the, so now the root node has been completed and the left hand, all the left hand side has been completed. Now it will go to the right child process, and again this pre-order statement will be continuously, this statement will be regressively checking the condition. And one more thing you want to find out, whenever the key has been represented as self dot key, and that time only the output will be produced, because we are having only one print statement. So and that time only the output will be produced. I'll tell you first. So first, this node has been executed and it has been produced the result. And after that, it will check whether self dot available or not. Yes, the self dot is available. So what will happen? This tree has been executed. This will be passed. So this root will be passed and this right hand side will be passed. So now it will check whether the self dot available. 14 having self dot left child. Yes, 14 having self dot left child. So now this statement will be executed. After printing this 27 and 14, this statement will be executed. Here it will print the 10 as my root node and it will be printing, and again it will check whether any self dot node is available. No, it is not available. If it is not available, it will be directly go to the right R child. It will be directly go to the R child and it will be printing that 19. And after that, this statement will be continued. This statement will be continued. It means all the elements has been printed here, and here all the element has been printed here. Now it will be moving to the right hand side. And right hand side, first thing we want to insert the root node. So it means 27, it will check 27 having either right hand part or what. Yes, 27 having the right hand part. So it will check self dot r child dot preorder. So now it will take this as the root node and it will print the message as 35. And after that root node, it will again check whether self dot l child is present for this particular root node. So after printing those root node, after printing all the root node, it will check L child as well as the R child. So it will print, it will check whether the self dot L child is present or not. Yes, the self dot L child is present. So again, it will check whether for this, now this will become the root node, and after that, it will check whether any self dot L child will be there or not. So there is no self dot L child, so it will be printing and it will be going to this statement again. So in this, after this condition is getting false, and after that, the right child process will be checked. And after that, this 42 will be displayed, and again it will go here. So this root has been already printed. So finally it will go here. This root has been already printed. Then this pre-order statement will be executed. That is the thing. So only one thing you want to remember here, we want to use the regressive technique, and first we want to print the self node. Whenever the target node is reaching the self node, that self node will be printed over in your output. So if you take one key and you can substitute here and substitute here and make this key as the process, then you can able to understand. We understand the concept for this or how it will be happens. Now you can see here the same result has been displayed: 27, 14, 10, 19, 35, 31, and 42. Only one thing, first you want to print the root node, after that the left child of your root node will be act as the root node, after that the left child of the left child will be act as your root node. So likewise it will be happen after completion of all the root node and the left child, then it will go to the right hand side, and after completion of this part and after that it will go to this right hand side. So that is the concept. So have you understand the concept? I want to explain it again. You just take the number and you can check it out over here, and now we will go with the next traversal method, that is in order. What is the process of in order?
The root node will be in middle, sir.
Left.
Yes. Now you can
It
tell
will
me
be
what
the
is
root
the
node
numbers.
right.
Left.
So now you can tell me what is the numbers for this.
10,
10,
14,
14,
19,
19,
27,
27,
31,
27,
31, 31,
31,
31,
35, 42,
42,
35.
35,
35,
42.
42,
35, and
42.
40. So yes. So here, when you are coming to this lines of code, same process will be happen. Same lines of code will be happen, but only one changes will be occur. Can you tell me that what is the changes will be? For this same lines of code, but only one change will be happen. What is that? First, what we want to check?
Left child.
First left node, sir.
Yes. First, we want to check the left node.
And print.
First, we want to check the left node. Same lines of code. It will check the entire left node. First, it will be check self.lchild. Yes, self.lchild available. Yes, it will go again. It will go to the pre-order technique, and again it will go to the self.lchild technique. So it will be available over here. So first, we want to check the left node. Then
Root.
In right node, whether left node is there.
that will be checking over here. It will be checking the root node. After getting this 10, we are going to, again. What is the first output? We are getting 10, and after that, what is the second output?
14.
14. 14 is the root node of 10 and 19, right?
Yes, sir.
Yes. So again, we want to check the root node first. So we are going to the root node. And what is the last step?
R child.
Right.
Right child. So that means the R child node. Again, we want to check the right node. So I am printing this
In order
root
or
dot
pre-order, sir.
in order.
Sir, in recursive function.
Recursive?
Sir, we define pre-order, sir, in order.
Okay, okay. Now you can see this output, that same process. First we are going to check the root node. First we are going to check the left node, and after that we are going to check the right node, root node, and after that finally you are going to check the right node. So that is the step. Same process, same regressive technique has been happened, but the condition we are implementing has been different. First here we have printed the first as root node, and after that left node, and after that right node. Here first you have printed the right node, after that root node, and after that first you have printed left, right, root, and right. So same, we have whatever you have given an output 10, 4, 19, 27, 31, 35, and 42. So this is an in-order technique. So now you can tell me how it will be coming for the post order.
Left to right to root node, sir.
Left, right, and
Left, right, and root. So now you can tell me for this example, you can tell me for post order.
10, 19, 14.
10,
19, 14.
19, 14. Then
31,
31.
42, 35.
31,
42,
42,
35.
35. Then
27.
27. So I have told you this condition to check whether you have done the correct traversal method or what. In your theory part, if they are asking now, you can check whether you have done three traversal has been correct. First, the root node will be in the first position, and after that the root node will be in the center position for in order. So in pre-order, the root node will be in the first position. In the post-order, the root node will be in the last position. For checking out, for manually, if you want to check that, you can check that and you can analyze those things. Now coming to the program point of view, how you can want to return this program?
Root node should be in last, sir.
Yes. First, you want to check the left child. Same, the regressive technique has been happened. First, we want to check the left side, and next,
Right side.
right.
right child. Next, finally, the root value will be printed.
Finally, root.
Means that all the value when the searching method, all the value are in the root condition only, it will be printed. Once it was searching over here, all the value want to be in the root statement. After that only it will print. So it will take, whenever it was searching the left hand side or a right hand side, it will take all the element as a root first, and after that only the result will be printed. So that you can keep that in mind.
So change that recursive function.
Post order.
Yes.
Indentation errors. Post order. Set def.
But post order, root node, post order.
Self.
Self. Now you can see here this the statement has been done. 10, 19, 14, 31, 42, 35, and 37. Now you can check that this in this stage the root will be in first, and this step the root will be in a center, and in the final step, that is in a post order, the root will be in the last. So likewise you can check those statement how it is working. So when it is a minimum number, then you can check. If it is a maximum number, it won't find out, and anyhow you will get a result when you are going with this operation. So here you want to learn only one thing here. The method for pre-order, in-order, and post-order, you want to have a clarity. First, what you want to print here is this root node that you want to clarity. And after that, you want to check whether the left-hand child is available. If this left-hand child is available, then you want to take this as the root node and you want to print that. And again, you want to check the left-hand side node is available. Yes, the node is available. Then this want to be take your root node and you want to print that. So likewise, you want to take the right-hand child, and all the node want to be your root node when you are doing this pre-order, in-order, and post-order technique. That is the thing. Clear about this, right? The code will be easy. It was nearly 12 to 15 lines, but you want to remember only one line. That means the recursive function for each and every node. Clear about this, right?
Yes, sir.
Yes. Now coming to the maximum and minimum value representation. Now we'll do the 27. 14. So delete we will see in the next class. We will discuss about the maximum and minimum value. Fourteen 35 and 10, 18. So now you can tell me manually. You can tell me what is the maximum and minimum value in this list.
41.
41 is my
Maximum.
அதான் அவங்களுக்கு தெரியும், நம்ம எல்லாம் சொல்லக்கூடாது. எத்தனை மட்டும் நம்ம கேட்கணும். அப்படித்தான் அவன் என்ன பையன்மா சில பேர்லாம் இங்க வந்து சேவை சென்டர் சொல்றா அப்படின்னு பையன், நமக்கு தேவையில்லை.
Sir, not audible, sir.
Sir, not audible, sir.
Am I audible now?
Yes, sir.
Yes. So what is the minimum number here in this tree?
10.
10 is my minimum number. So now you can tell me where the maximum and where the minimum number has been located.
Minimum Left. left side.
Minimum number is in the left side of this root node and left side of this root node. So minimum number will be always in the left side, right?
In leaf. Yes.
So anyhow, in the tree, the minimum number will be always in the left side.
Yes,
Am I
sir.
right? Yes. So the maximum number, it will be always in the right side, right?
Yes, sir.
Yes. So now if you want to find out the minimum value, where either you want to search in the right side for minimum value, whether you want to search in right side.
No,
No,
sir.
No. So here also you no need to search, right? Here also you no need to search. For this two element only, you are going to do the search operation. Which one is the minimum? So this also you can avoid because this is a right hand side of this particular node. So it can't be a minimum value. So if it is 14, then 19 cannot be the minimum value. So you want to search in the left hand side for this minimum value. So same as like that, you want to search that in a right hand side process also. You no need to worry about the left hand side. So if it is 35 is your maximum value, and if 35 having any right node, then that particular right node will be your maximum value. So don't bother about your left hand side. So that is the thing. So for this, how you will write the code? Simple.
Calling root node on the left side.
How you will write the code?
Sir, for minimum calling root node and checking left side.
Yes, first it will take the root node. Take the root node and it will check any left child is available or not when you are going with the minimum value, minimum value. If you are going with the maximum value, you want to check whether any right child is available or not. So first you will write the code for minimum node. Whether you want to pass any arguments here?
Self.
Self. So default argument only, either then there is no user input argument. So here current is equal to self node. So first what I have declared, current is my self node. That is 27 is my self node, right? 27 is my self node. So first I want to do that. First I want to check whether current node is having any right child or left child or not. So finding out the minimum value, want to traverse in the left hand side. So first I want to check whether any left child is available or not. So current dot L child. Now what will happen? Current is equal to current dot L child. Yes. Yes. Now you can see here this. So here I have written the code for finding out the minimum node. For finding out the minimum node, I want to traverse in the left hand side, right? So first I am taking this current is equal to self, that is my root node, self is my root node. So current is, I am taking first current is equal to 27. So it means if this 3 node is not available, if this 3 node is not available, and this is my minimum node of the tree, right? Am I right? Yes? Yes.
Sir.
So here first we want to do that whether current is having any left child or not. Yes. So this is the current node, and I am taking this current is having the left child or not. Yes, current is having the left child. So now the current has been changed. Now this will be your current, and this will be your current. Again, it will go here. Current is equal to self. The current node will be taken. While current is, again it will check whether current is having left child or not. No, the current is having, yes, the current is having the left child. So now this will act as the current node. And after that it will check while current dot L child. For this 10, current having any left child here?
No, sir.
No, sir.
No. If the while loop has been terminated, it will be directly go here and it will print the smallest node in a tree is that final current. What is the current node, and for that particular current node, what is the key? That key will be printed. The smallest node will be the 10. So if I am calling this root dot underscore node. You can see here the node. The smallest node in a tree is 10. So you know that the smallest node will be occur in the left hand side. If you are having one child, two child, one node, two node, three node, how many nodes are there? Anyhow, the smallest value occur in the left hand side. So that is the thing. So the smallest node is in the tree is 10. So that will be displayed. So first what will happen? It will take this as my current node. And if it is the left child is available, and that left child will act as a current node. If the left child is available, this child will act as a current node. If it is not available, final current key value will be printed as your smallest number. You can take any example and you can work it out here for this purpose. And you can tell me this, what want you to do for the maximum node? What do you want to do for the maximum node?
It's the same process, but in current is equal to R childs.
Well, current dot is equal to R child, and here the current dot is equal to R child. Is this right?
Yes, sir.
Yes. So I want to print this, right? Root dot maximum underscore node. So now the largest node in the tree is 42. So the concept will be simple. The smallest node want to be searched by in the left side of all the nodes, and the largest node want to be searched in the right side of all the nodes. So most probably the traversing method and the finding out the minimum and maximum in a tree would be very easy. I hope so. If you understand the concept, it will be very easy. Are you clear about this two things?
Yes, sir.
Yes. So in this next case, what will happen? The next only one statement is there. So only one condition, only one operation will be pending in this. So that is the delete operation. So delete operation will have a huge number of lines of code. I'm trying to get the shorter lines of code for this delete operation. Once I got in this, and then I will be going with this delete operation. So before going to this delete operation, can you tell me how many types are there in the delete operations?
3, sir.
Yes.
3, sir.
Yes. What are there?
Single child.
Yes, the node will the node which have single child, then
2 child.
2 child, then
No child.
No child with
no
No
child.
child.
Yes, yes. For this, the node which have 2 children will be very difficult. Why? Because any one of the child want to be act as the root node, right?
Yes, sir.
So you
Yes,
just
sir.
imagine, if I am deleting this 6 here in this, if I am deleting 6 here, what will happen? Either we want to take highest number, lowest number in the right hand side,
Highest number.
lowest number in the right hand side, and highest number in the left hand side. Am I right?
Yes, sir.
Yes. Why? Because I have told you the insertion operation that will be opposite when you are coming to deletion. How you will insert? The lowest number will be in the left hand side and highest number will be in the right hand side. When you are going to delete this, the highest number in the left hand side want to be represent the root node, and lowest number in the right hand side want to be represent the root node. So here we were first for deleting this node will be easy. The single child node, so this will be considered as your null. It will be represented. This will be easy, and deleting this node will be also easy. So one here also it has no child. So the deleting this node will be easy, and deleting this node. So most probably the one child and the zero child node will be as of like that same. And the only trouble I have facing is when you are deleting to 2 child node, we want to do a calculation whether we want to go with the left hand side or we want to go with the right hand side. If you are going with the right hand side, then the minimum value want to be taken and want to replace the node. If you are going with the right hand side, the maximum value want to be taken and you want to replace with the node. So that is the thing I will be working into it. So next class we will discuss about the deletion operation as well as the AVL tree methods. So as of now, this is your syllabus. So till now we have completed the binary search techniques, and here the delete operation has been pending here. And next class we will see the delete operation as well as the AVL tree concept. So AVL tree is nothing but the the height want to be very similar. So here we have taken the example. So here you can see here whether this is a binary tree. Whether this is a binary tree.
Yes, sir.
Yes, this is a binary tree. But you can see here the height of the left hand side and height of the right hand side will be differ, right?
Yes, sir.
Yes. Then we want to do the reprocess operation for this particular tree to bring this tree as in an even structure. We want to do the reprocess technique to bring this particular tree in an even structure. The even structure, it will be consist of this one will be represented like this. Anyhow, it will be completed. The root node will be changed. Based upon the changing the root node, and you want to find out this tree with a complete tree. So that is the thing of AVL tree. AVL tree that we will discuss. That we will discuss the concept in the next class. When we will discuss the delete operation code also in the next class. So any doubt as of this two concepts, that is tree traversal and minimum, finding out the minimum and maximum thing, you can stay back and ask your queries, or else you can give your attendance and you can leave.